During the demo, we will invite the attendees to interact with our tool by first selecting a dataset from the list of the available datasets, such as LDBC dataset representing social network, CityBike representing the history of bike rentals, Smart Factory representing the different dynamic connections found in smart factories. We will describe how each of the datasets can be modeled as a temporal property graph. Then, attendees will be invited to select between the different available queries written in natural language. Examples of such temporal queries for the LDBC dataset are: return pairs of users who became friends when studying at the same university. Given a user, return the newest 3 posts liked by his friends. Given a person, return the 3 most recent reply comments to all his posts from friends or friends of friends created before a date. Note that some of these queries are extracted from the list of temporal queries defined in the LDBC benchmark. Now, examples of temporal queries used in the CityBike dataset are: return the average duration of trips between 2 given stations. Given 2 stations, A and D, return the latest departure time from A of a trip arriving before a given date at station D. Now, by referring to different real-world scenarios and displaying for each a list of temporal queries, we hope to prove the usability of our tool and the additional information that one can gain from including time into queries. Now, the selected query will be displayed as a T-cipher query, which will then be translated into a cipher query that is semantically equivalent. We hope that by also displaying the cipher query, attendees will be able to clearly detect its verbosity and have a clearer insight on the importance of our tool in making reasoning about and writing temporal queries more natural. Finally, the cipher query will be evaluated and the returned results will be displayed. Now here's an example of a query from the query list of LDBC. This query retrieves all the users whose friendship started when studying at the same university and continued after graduation. Now this constraint corresponds to the semantics of the starts operator, which is used in the T-cipher query. It's notable that the cipher equivalent query is much more verbose as compared to the T-cipher query, because the temporal constraints of the time slice and temporal operators are expressed with cipher's built-in constructs. Now let's also discuss one query example from the CityBike dataset. This query returns the bike ID of the trip that took less than 2 hours between 2 given stations, with at least 15 minutes of rest time at each intermediate station. In the T-cipher query, we use a sequential path to indicate that the departure time from the station follows the arrival time to the same station. Besides, we used a minimum delta duration to indicate that at least the rider waited for 15 minutes at each station. Now, besides the temporal constructs presented in these 2 queries, we will also discuss the semantics of other constructs. Particularly, we'll explain the different types of temporal relationship patterns, when to use each type, and how to include it in the queries, and emphasize the verbosity of the cipher queries when translating temporal relationship patterns. Finally, we are also planning to improve the design of this interface. Thank you for your attention.